Okay, this is the relationship between pH and pOH. What have we always known our scale to be on? 0 to 14. pH, if you add it to pOH, it's 14. So, if you ever have pH, you can always find your pOH. And if you have your hydronium ion concentration, you can find, if you have at least one of them, you can find all the other parts of that question based on the fact that you know that pH added to pOH is going to be 14. Okay, so an example question. All I would have to give you is, let's say, hydronium ion concentration. And you should be able to calculate pH, pOH, and then hydroxide ion concentration based on having just one piece of information from that, okay? So let's do one. So calculate pOH, pH, and hydroxide ion concentration if a solution has a hydronium ion concentration of 2.85 times 10 to the negative 3 moles per liter. Okay, so I only have to give you one of those things. We're going to work out how it is, what's it like to actually get everything in that question. Okay, that's how they're associated. That pH level is always equals to 14, so it's kind of neat that way. It's not always been a coincidence that it's just 14. Okay, all right, so if we have hydronium ion concentration, okay, so this is where it's really tricky as well, that some people have to remember. You can only compare pH to hydronium, and you can only compare pOH to hydroxide, okay? Then you have to use that pH plus pOH equals 14 to be able to compare the two, okay? So, if we have hydronium ion concentration, what's the next value that we can calculate easily out of here? pH, okay? So let's calculate pH. pH is negative log of that 2.85 times 10 to the negative 3 moles per liter. Okay, now we're going to keep the same amount of significant digits. So how many significant digits is this in real world? 3. Okay, how many decimal places is this in acid-base world? 3 decimal places. Okay, so negative log 2.85 times 10 to the negative 3. We're going to get 545. Sorry, 545. 545. Okay, sorry. 2.545. That's my pH. Okay. What can I calculate next, do you think? pOH. Okay. So because I know pOH is the relationship of just adding pH and pOH together to make it 14, all I have to do is 14.00 minus 2.545 to make it equal my pOH value. So 14 minus whatever number I had before, I'm going to end up with 11.455 as my pOH. Okay? Sound good? Now what's the final number that I can still calculate here? Can I now calculate my hydroxide ion concentration? Yeah, man. Okay, so 10 times, or 10 to the power. Now guys, this is the other thing too, especially with pH, leave everything in your calculator. Don't round anything until the very end of your final answer, okay? So this number should have been carried through all the way through your calculator. Don't don't just put in 11.455 and then that's it. Keep it what was here. So 10 to the negative answer, okay? So negative 11.455, whatever you had in your calculator, okay, equals 3.51 times 10 to the negative 12 moles per liter.